shortly following the 9/11 attacks, I was asked to build a infrastructure for the world's largest legal organization, and they wanted to absolutely make sure that they had zero data loss between their sites. You see, at that point, they only had Site A data being backed up, Site B data being backed up, and Site C data being backed up, and then they would store that data off-site. But they were concerned that if they had an attack on any one of those sites, that they would lose critical data. So they wanted to make sure that they could replicate data. Remember, synchronous replication is the confirmation that the data has been successfully written to both of the sites. So in this example, we have Site A there, represented by the gold database, and it is replicating to Site C and Site B. Now, when Site A writes the data, it waits to complete the transaction until Site B and Site C report back to Site A and say, yep, I'm good to go. I wrote my data. Now, you don't have to have a two-way synchronization here. You could just have it between Site A and Site B, for example. But the point that I'm making here is that synchronization requires a confirmation that the data is written. That confirmation can really impact performance of that application. You see, the transaction, if it's a data structure or a database, it's going to wait for that to happen. And so you're going to see that in the application as it pulls up the next field of data. It's going to wait until it's synchronized. And so the cost to do a fully synchronous model over a 500-mile geographically dispersed area can be quite expensive. But there is an alternative. And the alternative we submitted to them continued to use synchronous replication, although synchronous replication occurred only at the local site. Notice there that you have Site A, and the gold database is the primary database, and the gray database is the target database of the synchronous activity. So in a different building at Site A, we synchronize the data. You see, if we're under 10 kilometers, that synchronization is very easy to do, and the cost is greatly reduced. Then we take the data, that synchronized data, for example, from Site A in the gray database there, which is the replicated copy, and then we asynchronously replicate that to Sites B and C. So that means that the data sits at all three sites, although the replication between the sites is asynchronous. Now, is this zero data loss? It's not. It's minimal data loss. So that means that if Site A were to go down, and let's say you had a campus of buildings, and the primary database was in building 1, and the replicated database was in building 22, if the attack occurs on building 1, then yes, the primary data will be gone. Although, because we have a synchronous relationship with building 22 at Site A, we're just going to replicate the data there, so our data is good to go. Now, if for some reason the site has, the primary database and the synchronized database, in this example, the gold database there in Site A and the gray database in Site A, if they're both sitting in the same physical location, well, then we have a problem. Then there is the potential of data loss, but the only data loss will occur is what was queued in that gray database at Site A before it asynchronously moved its data to Site B and Site C. So there is, with a knowledge of technology, understanding the technology that's available, understanding these primary decision points between functionality, performance, manageability, and physical accountability, we can design architecture and solutions that are both cost-effective and meet the business requirements for any organization.